So I will be explaining problem 6b on Expert TA, which is asking for the acceleration of a block on an incline. And so in part A of 6b, we found the equation of the acceleration for this. And so first, to find the equation, you had to draw a free body diagram of the two masses. And so when you look at the free body diagram, you have to draw in the mass 2, the gravity pulling on mass 2, the gravity pulling on mass 1, and the force normal. But then you have to remember that you have to include the vertical and horizontal components of gravity. And so the horizontal component, which is m1g cosine of theta, is going to be going in the opposite direction of force normal, but they will be equal to one another. And then the vertical component will be mass 1g times sine of theta, which is going straight to the left down the block. And at the end of the mass 1g sine of theta, you have to include the idea that there's going to be some sort of friction going against the block. So that's going to be mu times force normal, which is equal to force of friction. And so once you make your free body diagram, if you do it correctly, it'll be really easy to make your equation. So you know that because everything's based off of Newton's second law, like 5a and 5b was, you know that Newton's second law is the sum of all the forces is equal to mass times acceleration. But this problem is asking for acceleration only, so you can change or modify the equation so its acceleration is equal to the sum of forces divided by mass. And so what I did is that I did A is equal to mass 2 times gravity minus m1g of sine of theta, because if you look at the mass 2 of gravity going down this way, you can see that m1g sine of theta is going in the opposite direction. And so it's contradicting itself because this one's going, because they're going in opposite directions, one is going to be subtracted from the other. And so then you do minus mu times mass 1 times gravity of cosine of theta. And so like I said earlier, mu is going to be the coefficient of the friction, which is going to be the kinetic friction as the block is moving down the incline. And it's multiplied by mass 1 gravity of cosine of theta, because as I said in the beginning, mass 1 gravity cosine of theta is equal to force normal, and the kinetic friction is mu times force normal, so you have to multiply it by the mass 1g cosine theta to make it equal to the force of friction on the object. And then you divide the entire thing by mass 1 and mass 2, mass 1 plus mass 2, because you know it's asking for the total system, the mass of the total system, which is going to have to be mass 1 and mass 2, not just one of them. And so I went through and plugged in the given numbers that I had for my equation. So my mass 2 was 8.7 kilograms, which is right here, times gravity. And then my mass 1 was 3.8, which is again multiplied by gravity. You can just follow in the equation. And so for my theta, I plugged in sine theta of 31 degrees, and then it's minus 0.35, which is my kinetic, my kinetic friction coefficient, times mass 1, 3.8 times 9.8, times cosine of 31 again. So just you continue to use the 31 degrees for your theta. And it's all going to be divided by the two masses added together, which is 3.8 plus 8.7. So the acceleration ends up looking as like 54.9077 divided by 12.5, which is equal to 4.39 meters per second squared. Thanks.